Hi, in my previous video, I have discussed fraction, multiplication, division, addition, and subtractions. Those operations are very important for calculating fractions, and fractions are key to enter the stage of secondary mathematics. So today, I'd like to rewind a little bit back to prime numbers and prime factors. I have discussed factors, I have discussed prime numbers. Now, how can you write a non-prime number as a product of its prime factors? That is a typical question one can usually see in GCSE exams. So for example, 6 can be written as 2 times 3. Since both 2 and 3 are prime numbers, and therefore they are prime factors of 6. So we write 6 equals 2 times 3 is a prime factorization of 6. The next example is 12. How can we write 12 as a product? Maybe you could think of 12 equals 3 times 4. Yeah, that's correct. But 4 is not a prime number, so we can continue to factorize 4. 4 is 2 times 2, or 2 squared. And 2 is a prime number. Therefore, we can write 12 as 2 squared times 3. That is prime factorization of 12. Next example is prime factorization of 72. Can you write 72 as a product of its prime factors? So we know a very common factorization of 72 is 8 times 9, but both 8 and 9 are not prime numbers, so we can continue to factorize 8 and 9. But 8 is actually 2 cubed. 9 is actually 3 squared. Both 2 and 3 are prime numbers, therefore 72 can be written as 2 cubed times 3 squared. And that is a prime factorization of a 72. Sounds very easy, right? You can somehow to prime factorize an unfamiliar number using the prime factor tree method. That is, try to divide a number using the smallest possible prime numbers, such as 2, 3, 5, 7, using this order, and until you couldn't divide any further. Put a circle around prime factors, and we can call those prime factors, or with a circle, as a leaf of the prime factor tree. And keep to factorize those non-circled numbers, because they are non-prime numbers, till you have all the leaves of that tree. So using that method, as you can see in this picture, we can easily factorize any number. In this example, I give 48 as an example to show the prime factor tree method. If you learned and understand this method, you can do a lot of questions in GCSE exams. Bye.